In this lecture, we will talk about ownership in Rust. Ownership is just a set of the rules that governs how Rust manages a memory. We only have just 3 rules that I written here. So each value in Rust has an owner. There can only be one owner at a time, and when owner goes out of scope, the value will be dropped. And this is why we don't need to manually allocate or deallocate memory, because Rust is doing this for us. We just need to follow these rules. Here we can see simple example with primitive variables. We just define 2 variables and print their contents. So nothing special here. You can run it and see that it's working. But now we can enter a structure into play. So it's very simple structure, it has just one member field, nothing special. And now we can try to do the same example but with structures. So I'll paste here. And you can see that now Rust complains about. So if we run it, it will not pass, and you see Rust will complain. So we can see that Rust behave differently for primitive types and for complex data types. So here in the first example, when you define this variable b, then Rust will copy the contents of variable a to b, and we will have 2 values, and each value will have an owner, and that's why we can use them both in this print. So in second example with structures, when we define this variable d, Rust will not create a new object or copy contents. It will just move the ownership from C to D. And then this variable d will become owner of this object. And this variable c will lose its ownership. And that's why you can't use it anymore after we define this d variable, and that's why Rust complains in this print statement. You can also lose ownership when you are sending arguments to function. So for example, I add here simple function that just print the radius, and this function accepts circle object. So now I will just comment this out, and now if you call this function and pass a variable like this, you see everything is work correctly, and you can also run it to verify this. But if you try to call this second time, let's say, you can clearly see that Rust complains, and that is because when you call it first time, then this ownership is moved from this variable d to this variable inside the function circle, and when this function finishes, then this owner goes out of the scope, and this object is released, and that's why it cannot be used anymore. So that's also why Rust complains if you try to use this object, because it's already released, so it cannot be used anymore. If you don't want to lose ownership when you are calling the function, then what you can do is just sending the reference of the object like this. So here, of course, you need also to change the signature of the functions. This. So now we didn't move the ownership, and the object is still usable after these calls also, and you can just run to see that work as expected. Usually for small data classes like this one, we want them to behave as primitive types, and only way how Rust distinguish between the primitive types and complex data types is that it looks if there exists copy trait on type. So the only thing that we need to do is to implement this copy trait for our specific type. Implementing copy trait for our type is very simple. You just need to define this impl block. and you can see that you don't need to implement any method. And this is, as I said before, there are some traits that are special, and compiler is aware of these traits and he knows what to do. And why we get the error currently? So if we go to this copy trait, yeah, as you can see, we see that it's empty. We don't need to implement anything, but we also see that this copy trait depend on this clone trait. So that means that we must also implement this clone trait. Also, if you scroll down a little bit, you can see that this copy trait is already implemented for all primitive types. And in addition to this, there are also some other types that a copy is implemented. For example, if you have some tuple that only contains primitive types inside, then copy is also defined for these types. So now as I said, we need to implement this clone trait. Implementing a clone trait is also very simple, so just need to define this impl block, and this trait lives in this clone module. So here is this clone, and for clone trait we need to implement this clone method, and only thing that you need to do here is basically dereferencing yourself, and you are done. We see that error is gone, and now this circle structure will behave same as primitive types. So here, if now we uncomment this line, we see that we don't get any errors. We can also run this. It's working. Also, we can also remove this if we like. For example, to remove this, as I said, this will also work as expected now. Also, as you can see, we implementing this clone trait, and it has clone method. So you can also now call this clone method if you like to cloning your object. So here also works like this, yeah. But you don't need to do this. It's when we have copy trait. As you can see, implementing these copy and clone traits are very simple, and it can be even simpler than this, because yeah, you don't need to write all this code all the time. So I will comment this out. Instead, you can use the Rust attributes for this. So here, after the hash and inside the brackets, there is deriv attribute, and inside parentheses you just specify the list of the trait that you want. So here we want this copy and clone trait. Yeah, and that's all. So, and everything works the same as all this code that we write before. And we can also just run to verify. And that's all for introduction to ownership. See you in next lecture. Bye.